everyone. Today we are continuing our study of linear equations, and today we're going to talk about solving them by graphing. You can solve an equation by graphing the related function. So the related function is just, we're going to take out 0 and make it be y. The solution of the equation is the x-intercept. So we will often use different words. So solution, x-intercept, 0, and root all mean the same thing. They're always going to be the x-intercept of the graph. So solve the equation, 2x minus 2 equals negative 4 by graphing. So the first thing we're going to do is we're going to set the equation equal to 0. So we're going to do 2x minus 2 equals negative 4. We're going to solve that by adding 4 to both sides. We get 2x plus 2 equals 0. Now, because we want to graph it, we need it to have two variables. So we're going to take out the 0 and replace it with f of x, which, remember, f of x is really just a different way of writing y. So now we graph that. So to graph that, I'm going to say that it has a slope of 2 over 1, has a y-intercept of 2. So I start at 2, I go up 2 over 1, then I follow that pattern backwards, so I go down to left 1, and I draw the line. I label the line with the function, because that is a graph of the function, and then my solution, or my root, is the x-intercept. So the solution is x equals negative 1. So now we're going to do some examples. So number 1, it's already equal to 0, so I'm going to make that be 3x minus 3 equals f of x. I graph that by finding the y-intercept, which is negative 3, and then I use the slope of up 3 over 1. Up 3 over 1. I draw my line. I label the line with the function, which is 3x minus 3 equals f of x. And then the solution, or the root, is where it crosses the x-axis. So it's x equals 1. To check our solution, we can solve it traditionally. So we can say 3x minus 3 equals 0. We would add 3 to both sides. We get 3x equals 3. Divide by 3, x equals 1. So this is our algebraic check. So number 2, to solve that by graphing, I need to first make it equal 0. So I'm going to subtract 8, which gives me negative 1 minus 3x equals negative 4x. I add 4x to both sides. So I actually get x minus 1 equals 0, which I make equal f of x. That has an x-intercept of negative 1 and a slope of 1. So I plot those points, label my function, and then the solution is where it crosses the x-axis, which is x equals 1. I can check that algebraically. So it's 7 minus negative 3 equals 8 minus 4x. I would add 4x. So I get 7 plus x equals 8. Subtract 7. X equals 1. I could also check it how I would check an algebraic equation by substituting 1 in. So it would be 7 minus 3 times 1 equals 8 minus 4 times 1. So this is 4 equals 4. Either check is appropriate. So I want you to pause, and I want you to graph and find the solutions to 3, 4, 5, and 6, and then come back. Okay, so as you can see, first thing I did on number 3 is I made it equal f of x. So I graphed that. That has a y-intercept of 4 and a slope of negative 1. And that means my x-intercept, which is my solution, is x equals 4. Number 4, I solved it to make it equal 0. So I subtracted 1/3 x and subtracted 2. And that gave me the equation f of x equals x minus 3, has a y-intercept of -3 and a slope of 1. I connected it, and my solution is x equals 3, which is the x-intercept. Number 5, again, I made it equal 0 by subtracting 1. So I have 2x plus 4 equals 0. So 2x plus 4 equals f of x. I graph that. My slope has a 2, and my y-intercept's 4. So I actually did the slope backwards. I started on 4, went down 2, left 1, down 2, left 1. Connected. My solution is x equals -2. Number 6, I solved the equation for 0, which gave me 1/2 x plus 2 equals 0, which means that has a y-intercept of 2 and a slope of 1/2. My x-intercept is x equals -4, which is the solution. Sometimes graphing does not provide an exact solution, but only an estimate. In these cases, solve algebraically to find the exact solution. Example, you and your cousin decide to walk the 7-mile trail to the state park to the ranger station. This is d equals 7 minus 3 point t, represents your distance d from your ranger station after t hours. Find the zero of this function, describe what this value means in its context. So I can graph this, which they did over there, and you will see that the 0 is not exactly a value. So I know that it's between 2 and 2.5. So to find my exact value, what I'm going to do is I'm going to solve this by making d equals 0. So it's going to be 0 equals 7 minus 3.2 t. I'm going to add 3.2 t to both sides. Gives me 3.2 t equals 7. Divide by 3.2. And that gives me that my time to walk to the ranger station is exactly 2.1875, and I believe hours. So Jessica wants to record her favorite CDs. The function C equals 80 minus 3.22n represents the recording time C after n songs are recorded. Find the zero of this function. Describe what it means. So again, I could graph that by doing the y-intercept is 80, and it goes down 3.22 every song. So every 10 songs, it's going to go down 32.2. So that's going to bring me at 10 down to like a little over 50. Then go down or I'm sorry, not a little over 50, a little under 50. Then go down a little bit more. And I get that it's somewhere between 25 and 30. Question is where? So to find out exactly what I'm going to do is I'm going to solve it algebraically. So 0 equals 80 minus 3.22n. I add 3.22n to both sides. And I get 3.22n equals 80. Divide both sides by 3.22. And n equals 24.8447205. So that means I can almost 25 songs, but not quite. Okay, so I want you to pause and try number 8 and come back and check. Okay, so you can see when I graphed it, I get somewhere between 6 and 8, probably around 7. When I solve it algebraically, I substitute C in for n, and it gives me that C equals 7.27 repeating. So that means I can buy 7 cups of coffee. On that gift card. Okay, if you have any questions, please bring them to class tomorrow.